Have you ever wondered why finding the values of x and y in simultaneous equations matters in our daily lives? Well, buckle up, because we're about to embark on a journey that will help shine a light on this mystery. You see, the world of algebra might seem abstract and disconnected from the reality we live in, but in truth, it's deeply intertwined with our day-to-day activities. Take financial planning, for instance. When you're trying to manage your personal finances, you're juggling multiple variables at once. The money you earn, the money you spend, your savings, your debts. They all form a complex equation that you need to solve to maintain financial health. And in the heart of this equation, you'll often find our friends X and Y. But it's not just personal finance. The realms of physics and engineering also heavily rely on the magic of simultaneous equations. They use them to calculate variables like speed, distance, and time, or to determine the loads and stresses on different parts of a structure. And let's not forget about logistics. Every time you're tracking a package online, there's a simultaneous equation working behind the scenes, calculating the quickest route for your delivery, the fuel efficiency, the traffic conditions, and so much more. So what are these X and Y we keep talking about? In the world of algebra, X and Y are simply placeholders. They represent unknown values that we're trying to find. And when we talk about simultaneous equations, we're dealing with a system of equations where we're trying to find the values of X and Y that make all the equations true at the same time. So as you can see, these equations are more than just letters and numbers on a page. They are tools we use to solve real-world problems. Now that we understand the importance of these equations, let's dive into the basics. Simultaneous equations are a set of equations with multiple variables that are all solved at the same time, hence the name simultaneous. They are like a puzzle where every piece must fit together perfectly. In our case, the pieces are the variables, usually represented by X and Y, and our task is to find their values. Variables are like placeholders. They represent unknown quantities that we're trying to figure out. Constants, on the other hand, are the known quantities in our equations. They remain unchanged and provide a solid foundation for us to build upon. The beauty of simultaneous equations is that they allow us to solve for multiple variables at the same time. Imagine trying to find the value of X and Y in two separate equations. It would be like trying to solve two puzzles at once, wouldn't it? But with simultaneous equations, we can solve for both variables in a single swoop. Now, how do we solve these equations? There are two main methods: substitution and elimination. The substitution method involves solving one of the equations for one variable and then substituting or replacing this variable in the other equation. On the other hand, the elimination method involves adding or subtracting the equations in a way that eliminates one of the variables, making it easy to find the value of the other. For example, if we have two equations, x plus y equals 10 and x minus y equals 2, we can add these equations to eliminate y, leaving us with 2x equals 12. From here, finding the value of x becomes a breeze. While both methods have their uses, it's essential to understand when to use each one. Substitution is handy when one variable is easily isolated, while elimination is useful when the coefficients of one variable in both equations are the same or opposites. With these basics in our toolbox, we're ready to start solving. The first method we'll explore is substitution. It's like a game of hide and seek with numbers. Let's take a pair of simultaneous equations as an example. Equation 1, x equals y plus 3. Equation 2, 2x plus y equals 10. In the substitution method, the idea is to replace or substitute one variable in one equation with its equivalent from the other equation. This way, we're reducing the problem to a single variable equation, which is easier to solve. So, in our case, since x equals y plus 3 from equation 1, we can substitute x in equation 2 with y plus 3. This gives us 2 times y plus 3 plus y equals 10. Now let's simplify that. Multiply 2 with both y and 3 to get 2y plus 6 plus y equals 10. Combine like terms and you get 3y plus 6 equals 10. From here, we're only a few steps away from finding the value of y. Subtract 6 from both sides to isolate y. 3y equals 4. Then divide both sides by 3 to solve for y. Y equals 4 divided by 3. Now that we have the value of y, we can substitute it back into the first equation to find the value of x. X equals 4 divided by 3 plus 3. This gives us a value of x, and voila! We've successfully solved the pair of simultaneous equations using substitution. This method can be especially helpful when one equation is already solved for one variable, as in our case. But even when it's not, with a little algebraic manipulation, you can always make it so. Remember, the key to substitution is to replace one variable with its equivalent, and then solve the simpler, single-variable equation that results. And there we have it, a solution found through the magic of substitution. If substitution is hide and seek, then elimination is like a magic trick, making one variable disappear. So how does this magic work? Let's dive in. We start with a pair of simultaneous equations. For instance, let's consider the equations 2x plus 3y equals 11, and 5x minus 3y equals 1. Notice anything interesting? That's right, the coefficients of y in both equations are opposites, 3 and -3. This is our golden ticket, because when we add these equations together, the y terms will cancel each other out. Or in other words, y will magically disappear. So let's go ahead and add these equations. The 3y and the -3y cancel each other out, leaving us with 7x equals 12. Now to find the value of x, we simply divide both sides of the equation by 7. This gives us x equals 12 over 7, or roughly 1.71. But wait, we're not done yet. We found x, but what about y? Well, that's where our second magic trick comes in. We're going to make x disappear this time. We substitute the value of x that we found into either one of our original equations. Let's substitute it into the first equation. 2 times 1.71 plus 3y equals 11. Simplifying this gives us 3y equals 11 minus 3.42, or 3y equals 7.58. Finally, to find y, we divide both sides of the equation by 3, giving us y equals 7.58 over 3, or roughly 2.53. And there you have it. We've solved our simultaneous equations by elimination. X is approximately 1.71, and y is approximately 2.53. And just like that, we've made one variable vanish and found our solution. We've journeyed through the world of simultaneous equations, uncovering the values of x and y. We embarked on a mathematical expedition, navigating the terrain of simultaneous equations. We understood their importance and how they serve as a cornerstone in algebra, helping us solve multiple unknowns in the same set of equations. These seemingly abstract concepts are not just confined to textbooks. They are omnipresent in our daily lives, in physics, economics, and so much more. Next, we revisited the basics of simultaneous equations. We went back to the beginning, to the very foundations, reminding ourselves of terms like variables, coefficients, and constants. We learned how to set up simultaneous equations, representing real-world problems in mathematical form. And we saw that the key to solving these equations lies in finding the values of the elusive x and y. Then, we learned about the method of substitution. We saw how this method relies on finding an equation where one variable is isolated, and then substituting this into the other equation. We found that it's a method that's particularly useful when one of the equations can easily be rearranged to get x or y on its own. From there, we moved on to the method of elimination. We learned how to manipulate our equations, adding or subtracting them in a way that cancels out one of the variables. We found that this method is often quicker and more straightforward, especially when dealing with equations that are not easily rearranged. And so we've arrived at the end of our journey. But remember, this is just the beginning of your journey with simultaneous equations. Continue practicing, continue exploring, and you'll find that the more you engage with these equations, the more they'll reveal their secrets to you. Remember, simultaneous equations are more than just math problems. They are powerful tools that help us make sense of the world around us.